Till now what we have seen? We have seen pressure enthalpy and temperature entropy diagram. Then we have seen the names of processes. After that we have seen assumption, limitations and drawback. Now what we are going to see, guys? We are going to see important relations of reverse Carnot cycle. So before going further, everyone give the heading. Important relations of what? Before going further, guys, give the heading. Important relations of what? Reverse Carnot cycle. Guys, give the heading. Important relations of what? Reverse Carnot cycle. Now the first relation that we are going to see, heat removed per kg. First relation that we are going to see, heat removed per kg from low temperature reservoir, means from the cold space, guys. Heat removed per kg from what? Low temperature reservoir. Try to see this one. Heat removed per kg from where? From the low temperature reservoir. Means what is, if you remember our VCR system, guys, see, low temperature reservoir. Heat removed from where? From the low temperature reservoir, guys. Heat removed from the low temperature reservoir, and where that heat is coming? Heat is coming to the what? That is evaporator, and that is nothing but our refrigeration effect. So here, if you so I am coming back to our discussion of this important relation. Heat removed per kg from low temperature reservoir, or we can say we are removing heat from low temperature reservoir, but where that heat is coming, guys? Heat addition per kg. Heat addition per kg in the evaporator. That heat is coming to the what? Heat addition per kg. Where that heat is coming, guys? That heat is coming to the what? Evaporator. Guys, try to understand the scenario. Or we can say it as what? Refrigeration effect. What we can say, guys? This one as what? Refrigeration effect. And that we denote by what? Q addition, guys. How we denote that one? Q addition. So this Q addition will be equal to what, guys? This Q addition will be equal to what? Just try to understand the scenario. This Q addition will be equal to what? H1 minus H4, guys. See this one. Just have a look at this, our drawing, guys. Pressure enthalpy diagram. See. 4 to 1. In 4 to 1, what is happening? Heat addition. And that heat addition is nothing but what? Our refrigeration effect, or heat removed from the cold space. Cold space means what? Low temperature reservoir, guys. What is the meaning of cold space? Cold space means what? Low temperature reservoir. So heat is removed from the cold space. That is 4 to 1. That is what? A heat addition means 4 to 1. Enthalpy of 0.1 is higher. Enthalpy of 0.14 is lower. So H1 minus H4. So what we can say? This relation will become what? Relation number 1. H1 minus H4. So before, and what will be the unit, guys? Unit of this Q addition will be what? In kilojoule, K small, J capital, kilojoule per kg, guys. So before going further, now write down this relation number 1. And if you are not given the heading, give the heading and write down this point number 1. Now the second point is what? What will be the second point? Heat rejected per kg to the high temperature reservoir. Heat rejected per kg to the what, guys? To the high temperature reservoir. Heat rejected per kg to the what? High temperature. Heat rejected per kg to the what? High temperature reservoir. And that is nothing but what? Our Q rejection. Means what is happening, guys? In this one, guys, have a look. What is happening in this 2 to 3? Rejecting the heat. So what is happening in this 2 to 3 guys? In this 2 to 3, rejecting the heat. So that heat rejection will be equal to what guys? That Q rejection, Q suffix Rej guys. This Rej must be in properly in suffix. So Q rejection will be equal to what? H2 minus H3, and that will be in what? Kilojoule per kg guys. That heat rejection H2 minus H3 will be in what guys? Kilojoule per kg. So before going further, please write down the point number 2 guys. Now point number 3 guys. COP. Point number 3 is what? Cycle net work input guys. Point number 3 is what? Cycle net work input, and that will be what? W net guys. That will be what? W net, and this W net will be equal to what? This W net will be equal to what? Q rejection minus what guys? Q rejection minus Q addition, and its unit will be in what? Kilojoule per kg guys. See, not Q addition minus Q rejection. Q rejection minus Q addition, that is what our W net guys. Just have a look here. So before going further, please everyone write down this point number 3. Now the next point is what? Point number 4 guys. What will be the point number 4? COP of Carnot refrigerator. What will be the point number 4 guys? Point number 4 is what? COP of what? Carnot refrigerator. What will be the point number 4 guys? COP of Carnot refrigerator. And we will denote what by? How we denote guys? We denote it by what? COP. How we denote guys? COP of refrigerator. But which refrigerator guys? Carnot one. And that will be what? TL, low temperature, divided by what? TH minus TL. See why we are taking TL in numerator, because in case of refrigerator our target is what? To maintain this constant temperature guys. In case of this refrigerator our target is what? To maintain this constant temperature. So that's why we are maintaining TL in the numerator guys. That's why we are keeping TL in the numerator, because in case of refrigerator our target is what? What is desired effect? Desired effect is what? To maintain the constant temperature. This low temperature we have to maintain. And here what is the meaning of TL guys and TH? Where TL means what? Low temperature. Low temperature, this temperature must be in, what will be this temperature guys? This low temperature must be in Kelvin. And then we have what? TH. TH is what? High temperature, and this high temperature must be in what guys? Kelvin. And this TL will be equal to what? Saturation temperature at P1 pressure, and TH must be equal to what? Saturation temperature at what pressure guys? P2 pressure. So here Tsat at P1 and Tsat at P2. So before going further, now write down the point number 4. Now point number 5 that we are going to study is what? COP of Carnot refrigerator we have seen. Now the next thing is what? Carnot heat pump. So point number 5 will be what? So what will be the point number 5? Point number 5 will be what? COP means coefficient of performance of what? Carnot heat pump. So this COP of Carnot heat pump guys. COP of heat pump, but which heat pump? Carnot one. So COP of what? Carnot heat pump will be what? TH. And in case of the heat pump, guys, what is the purpose of heat pump? To maintain the high temperature. So what is the purpose of heat pump, guys? Heat pump is to maintain the high temperature. So in numerator here, that's why we are taking TH in the numerator, guys. And then by default, TH minus TL, guys. Try to understand the scenario here, guys. So in this way, we got it what? COP of what? Carnot heat pump. So before going further, please write down this relation number 5, guys.